Hello, everybody. This video relates to my book on physics, this part 1. So in that book, there is lesson 0. That is the introduction to physics, and mainly covering certain important aspects before you embark on a journey to study physics. So it is lesson 0. At the end of this lesson, you should have a general idea about scientific method, and you should be able to apply that. You should know the correct approach to solving physics problems. And we will talk about 1 or 2 important mathematical formula. I'm just going to write those formula. I'm not going to derive, because this is not a mathematics lesson. This is a physics lesson. A bit about the importance of certain key skills. I'm going to talk about 6 key skills. I'm only referring to these key skills because I have developed models where students could study anything but improve these 6 key skills that are important to their lives in the future, be it professional or social settings. So the first is to improve the communication skills. It could be writing, it could be verbal, but it's important to improve your communication skills. You get many opportunities when you study online classes, because you have discussions where you get an opportunity to answer questions and at the same time interact with your fellow students. Then also, you should improve your number skills, or rather application of numbers. Because we are not asking you to be experts on maths or mathematics skills. We are just asking you to improve your basic application of numbers. So communication, application of numbers, then IT skills. So in an online class, you get to practice all 3. So you might ask, what about on ground class? You get to talk to each other. Yes, in discussions, you can actually post videos. Your answer could be in the video format. The 4th skill is you should learn to work with others. Work with others. Especially scientists are good at conducting experiments or research, but they like to work in a lab in an isolated place. But that's not the way to improve your abilities and to progress in your career. So you should be able to learn to work with others. Otherwise, you will be not only isolated, you will always stay at the same level. In your promotions, you will always be at the same level. You would not be able to be a manager or be a leader in your workplace. The 5th skill. So this is given in the first chapter of my book. I'm just writing it down to make it easier. And sometimes I might refer to the chapter for you to check on. So when you're watching these videos, you should have your book open and follow it through. You need to be able to improve your own learning, because when you join the workforce, nobody's going to come and ask you to learn something new or maybe improve your knowledge or a skill, because it's up to you. Otherwise, you will stay at the same level at your workplace. You will not get any promotion. So improving your own learning is important. When you're in a college, the professors encourage you to learn and improve your knowledge and skills. But that doesn't happen at workplace because you are independent. So you need to do this on your own. So when as you have enrolled in this course, you should go and do more questions and look at the way the questions are written. And it could be the same problem, but written in a different way. So you have to look at it from a different perspective. So that is improving your own learning at this level. The last one is problem solving skills, or it is the lateral thinking abilities, problem solving. So when you study physics, try to improve these 6 key skills, even if you are not going to major in physics or, for that matter, in science. Okay. Let me move on to the scientific method. This is the singular important concept we teach as science professors, any science. And you can apply this to any other subject or in your day-to-day activities. Here we identify a problem. You have to first identify a problem. Identify the problem or the question. So we'll say in an exam it to be a question, or in a research it to be a question or a problem. It could be in the social settings that you have to identify the problem. So we'll say you are visiting a friend, and then you knock on the door and nobody answers. The problem there is somebody at home, or is your friend at home? Then you make an educated guess, which is we call hypothesis, to the problem. It's your answer from the educated guess. So that's where the experience and knowledge come together. But so we say you knock on the door, nobody answers, and you just look into the driveway, his car, or their car is missing, and then lights are not on, then you can say they're not at home. Okay, so you try to come up with a statement that is the hypothesis. So I'm teaching you the scientific method. I'm briefly explaining it to you using a problem in social settings. Then you're going to test this hypothesis. So there are different ways of testing this, testing the hypothesis. Maybe you do an observation, you do a survey, you do a questionnaire, or in science, you do experimental. That means you're carrying out an experiment. Okay. Then from those, you get the results. You check, you get the results, and you interpret them. Okay, so one of the things, so the social setting, you knock on the door, nobody's answering, you check there's the lights not are turned off, then there's no vehicle on the driveway. So you say, okay, my hypothesis is my friend is not at home. Then you do some tests. Maybe you can make a call, or we can see whether the phone is ringing, or you can see whether any sounds coming. So you carry out those observations. They are observations. There's nothing to question. You maybe a question setting would be you ask the neighbors, anybody, have you seen him at home or her at home? So then you interpret and said, okay, so my friend is not at home. Okay, and then you report your results. You interpret, then you report them, the final, and you see whether it confirms your hypothesis. If it confirms, you accept or deny it. You reject it. You accept or reject. If you reject it, then you have to come up with a different hypothesis and you test that. So that is scientific method in a nutshell. All right, so now I'll move on to talk about the solving problems. In physics, always the wording of a physics problems may cause difficulties to understand what they're asking or even apply. Solving problems. Okay. So if you follow this method, later on you don't have to follow exactly like that, but you should be able to get somewhere and get an understanding where the part of difficulty in the writing of the question, even you can recognize, then you can do more research and find out what they're asking exactly, because it's the way sometimes the physics questions are worded might bring confusion. All right, so this is method. So first, let us say an example. The example given in the book, as I said, you have to have the book open. A car accelerates, we take this question. Now you don't know any of these physics things. I'm assuming you may have done it in your high school, but let's go with that. You don't know anything about it. But so the question is a car. I'm not going to write the whole question because you should have the book with you. A car accelerates rate 0.6 meters per square second. And the question is how long. They're asking the question. How long does it take for the car to go from 55 miles per hour to 60 miles per hour? Okay, so you can see when we go on to the next chapter, we'll be studying about units. We will see that there are two different units here. Okay, so handwriting here may not be clear because these are unedited videos. I'm looking at the book and trying to teach you this. These are the lecture substitution for that book. So 0.6 meters per second, they are SI units, standard international units. We will know more when you come to that chapter, which is the next chapter. This is chapter 1. Then here, 55 miles, I put MI, 60 miles per hour. So they're asking is, car accelerates 0.6 meters per second. So acceleration is given in these units. We'll learn later. So for a car to go from 55 to 60, if the acceleration rate of acceleration given like that, how long it takes? They're asking the time. Okay, so when you have to solve this, even if you don't know what the equation to solve, so first is you write down the givens, or the givens that you can derive from the equation. So the given is, I put A for acceleration is 0.6 meters per square second. Then initial velocity, O as initial velocity, or you can put I to denote initial. Okay. And then is 55 whole thing miles per hour. Then the final velocity given VF, V1 and VF, it's the same thing. Learn that. So maybe you can go by VI and VF. As long as you follow through this question the same symbols. Okay, don't change the symbols. Okay, so this is VO. Okay, sorry, because it's VO, we'll put V, VAI, VF. Okay, so then this is 60. Now, so these are the givens. So when solving problems, we follow this called GUES. S, G for givens. Okay. U for unknowns. UK, right? Unknowns. This givens unknowns. So unknown is the time. So first you write down the givens, unknowns. And they are asking the question, how long does it take? So they're just asking the value, but you have to know in which unit. So because it's in seconds, so we will try to express it in units. But if it's a multiple choice, you look at the answers given, they will be given seconds or hours, but we'll stick to several seconds here. Okay, so we have to give it in seconds. It's in seconds. All right. Then you have to add the equation. But before you do the equation, you have to know the principles involving this sort of kinematics in physics. Okay, so I will tell you the equation now because you haven't studied it. So that is where E comes from, equation. The equation is free to use. It's V equals VO plus AT. So remember, this V means final, right? VF, and VO means the start one. AT. A is the acceleration, T is the time. Now we know all those symbols. So if I'm just going to do it like that, this, two ways is the best way is to convert this first, but to fit into this equation, I will just write down whatever there. So the last final is 60, but remember miles per hour equals initial is 55. So I'm following this equation. This is E, G-U-E, G-U-E. I'm just writing the values in those units. I have to convert them, but just to show you, I'm writing them right. Per hour. And acceleration is equation is plus acceleration is 0.6 meters per square second times t. So t is the unknown. Okay. Now this S stands for substitution. Substitution. You have substituted the values to this equation, but then the final one is solution. But you can't find a solution until you convert these. Okay, that is dimensional analysis. You convert them. Now conversions, I'm not going to show it. It's shown in the book. But I'm going to show it is because we haven't studied the conversions, right? So we'll say just this was not given. So the conversion factors you have to find out. Sometimes when a question like that, they give you when you have to convert from SI to US customary or British imperial units, but they will not give you when you have to convert from SI one from SI to the other, like from meters to millimeters or something. There, that you have to know. Why you have to know? Because they are easy. It is 10 by 10. That is chapter 1. Talk about that. So we'll say if I give you the 60 miles means okay, let us make it a bit easier. So 60 miles per hour this side. I bring this 50 miles to the other side. So I have 60 minus 55 all in miles per hour. And then on this side, I have 60 meters per square second. So you have a choice of converting because here 5 miles per hour, 0.6 meters square second times t. So it's easy, instead of converting to 60 and 55, we get the difference and convert 5 miles. Now, when I convert 5 miles, I'm just giving you the conversion is 2.2 meters per second. The conversion. When I convert the entire 5 miles per hour, I get 2.2. How did I get 5? 60 minus 55 is 5. Then I get 0.6 meters per square second times t. Okay. So now I have all of these things in the same units. Now it's a matter of getting t. So I get t by 22 divided by 0.6. Top I get meters. So this underneath s, like a denominator, I can also express like that. And this I can express -2 like that. And then I have t on this side. So meters will cancel. -1 will cancel to -1. I'll be left that. Then 2.2 divided by 0.6. So I get the answer. I get 3.7 seconds is the time. Okay. So when this -1 go up, it becomes 7. When I divide this 2.2 by 0.6, that's what I get. All right. Now you have got the answer by following givens. You have put the givens, and you got the unknowns, you got the equation, you got the substitution, and the solution. You got it. All right. So everybody, so this is how you use this guess method. It's not a method as such, but I'm telling you the methodical way, the logical way to solve a question. All right. Okay. I plan to make this video a short video, so you're not watching it for a longer time, and then so I'm going to stop it there, and I will cover the rest of the chapter 0 in my next video.